Hey everybody, so today this video was put together so I can help walk you through the practice if you're stuck. Just keep in mind you're going to want to use your graphing calculator. So let's take a look. Amy tossed a ball in the air in such a way that the path of the ball was modeled by this equation. All right, and think about what would happen if you tossed a ball into the air. All right, it's going to go up and then it's going to come back down. All right, so that's the shape that we're going to see. And I knew that it was going to be concave down because of this negative. All right. Now I don't see anything added or subtracted here, so that means that you're going to be starting down here at the origin. That's going to be your y-intercept. Because otherwise, if it was starting at 6 or whatever, you would see a plus 6 at the end. Those are all just little shortcuts, but remember we have our graphing calculator. So it says graph that equation for the interval from 0 to 6. So that means you just want to use x's from 0 to 6. So I'm going to get that set up. So 0 to 6 is what we're using over here. 0, 1, 2, 3, 4, 5, 6. All right, so let's clear this out. Negative x squared plus 6x. All right, so take a look at the table by hitting second graph. So 0, 0, 1, 5. We're just going to copy that down. Now, the reason that they're having us just go from 0 to 6 is because we have negative numbers after that. The ball is not going to go underground, all right? And you're not going to have negative time. So let's graph it. So here's your y-intercept, your starting point. So remember, she's tossing the ball in there. So it leaves the ground. It's going to go up and come back down. So 1, 5, halfway between 4 and 6. 2, 8. 3, 9, halfway between 8 and 10. 4, 8, because remember 3, 9 is your turning point, your vertex. 4, 8, 5, 5, and 6, 0, it's back on the ground again. Okay? So then carefully connect the dots. Remember, we don't want to put arrows because we don't have negative time or a negative height. And give it a label. All right, let's answer some questions. At what time x is the ball at its highest point? Well, our highest point is up here at the max. So the tallest that ball gets up to is 9. And you can find that right in your vertex as well. And it's the height of the ball in feet, so 9 feet. What's the ball's maximum height? Oh, what time? Sorry, I mixed those up. So 9 feet is the maximum height. And at what time did that occur? 3 seconds. Okay. For how long is the ball in the air? Well, it goes up, comes back down at 6 seconds. So from 0 to 6, it was in the air for 6 seconds. And that's it. So initially, those equations might look really tricky, but with the help of your calculator, you can easily figure those out. All right, I told you don't have to do number 2, but for those of you that did, I'll go over it. It's not bad practice here. So there's your equation. If you type that into the calculator, you are not going to see the turning point. So I'll save you the time. So it says algebraically determine the time. So time is your x value and your turning point, which is also your axis of symmetry. So x equals negative b over 2a. Negative 16 is your a. 125 is your b. So negative b would be negative 125. 2 times a, 2 times negative 16. Wow, what is that? All right, so we have negative 125 over 2 times negative 16, which is negative 32. Throw it into the calculator. Second mode will get you back to the home screen. Negative 125 divided by negative 32 is positive that. All right, so x equals positive 3.90625. So that's the time in seconds. All right, so about 3.9 seconds. If you want to actually figure out the height, why don't we change this to a fraction? Math, enter, enter. Make it a little easier to work with. 125 over 32. All right, so if you want to figure out the maximum height, plug that into the original equation. So y equals, you don't want to just round it because then it won't give you the exact value. Use this actual fraction, 125 divided by 32 squared plus 125 times 125 over 32 plus 15. Now, a shortcut to put it into the calculator, I've already changed it to a fraction. Remember, if you hit store x, it'll take that answer and store it for x, hit enter. So now I can just type in negative 16 x squared instead of typing in the fraction each time, plus 125x plus 15. That doesn't really give me a height, so change it back to a decimal, and you can do that by hitting math, and instead of hitting 1 to get a fraction, go down to 2 to change it to a decimal. All right, so it's approximately, which we'll use these little squiggly equal signs, 747.4 feet. So a little bit more complicated when you have to do it by hand. But again, this isn't something you'll have to do by hand until you get to Algebra 2, so you can focus on questions like this where you can get it using the calculator. All right, question 3. Almost done with this packet. So here's your equation. The height and feet of a basketball that's thrown can be modeled by this function where x is the time in seconds after it's thrown. Find the time it takes the basketball to reach its maximum height, which would be at the vertex, right? So again, I can see there's no number being added at the end, so it's going to start at 0, 0, it's going to go up, and whoa, and then it's going to come back down. So basically, you're looking for the x value in your vertex. So let's put it into the calculator and take a look. Y equals, hit clear, negative 16x squared plus 32x. Oh, wow. Right there. Let's copy that table down. All right, so find the time it takes the basketball to reach the maximum height. 1 second. Right there. There's your vertex. Wow, what is going on here? I definitely prefer writing on paper. Find the basketball's maximum height. Well, that's also in your vertex, 16 feet. When it says explain, you can show this table. You could even sketch that graph. Okay, a model rocket is launched from ground level. Its height, h meters above ground, is a function of time, which is using t instead of x, seconds after a launch is given by this equation. Determine algebraically, we're just going to determine it. We're going to use our calculator to help us. The maximum height to the nearest meter. So again, that's going to be the y value in your vertex. Okay, so let's put it into the calculator and take a peek. Negative 4.9 x squared plus 68.6 x. Take a look at the table. Ooh, Got a lot of numbers here. Look for where they repeat. Oh, right here. 220, 220, 235, 235, 7, 240.1. All right, that's straight from the table. So the maximum height that the rocket is going to reach is 240.1 meters in this case. And you get that by plugging 7 in for T. All right. Last one. The height of a swimmer's dive off a 10-foot platform into a diving pool is modeled by this equation. All right, so I want to point out this is positive. So we're going to have a U shape, but think about it. If they're diving into the water, they're going to dive in and then come back out. All right. So X represents the number of seconds since the swimmer left the diving board, and Y represents the number of feet above or below the water's surface. What's the farthest depth below water's surface that the swimmer will reach? All right. So let's first get our table together. Go to your calculator, go to Y equals, and type that in. So Y equals, we'll hit clear, 2x squared. First one, let's see. First one we've had, that's positive. Minus 12x plus 10. Take a look at the table. All right, so we're going to start at a time of 0, 10, and go to, well, let's just go to 10. So 0, 10, 1, 0, 2, negative 6, 3, negative 8, 4, negative 6, 5, 0, and we'll just add 6, 10 back on just for the heck of it here. All right, so let's envision this. The height of a swimmer's dive off a 10-foot platform. All right, here's the lowest they're going to get into the water. But let's sketch this. So here's your x-axis, and that basically is your water. That's the surface. So the y-intercept is 10. That means that's the swim platform. So they're diving off of the swim platform, and they're going to go down into the water, and then they'll come back up. All right. So it goes down to negative 8 is the lowest point it gets to. So like 1, 0, it took 1 second before they actually hit the water, dove down in after 3 seconds, and then they came back up and hit the surface at 5 seconds. All right. So it says, what's the farthest depth below the water's surface? That's going to be negative 8 feet. Or you can just say 8 feet below the surface. Okay? All right, so that's it for this unit. A little bit of lots of practice with quadratics. The word problems aren't so bad, especially when we have our calculator to help us. We'll do some review, finish with a test, and then we'll move on to our next unit. If you have questions, email me or stop by the math lab.